Good morning. Alrighty, so we're gonna pick up with part two this morning on your STEM anatomy. So, um, so yeah, more fun drawings. Alrighty. So yesterday we kind of briefly went over what dicots and monocots are, because like I said, the reason why is they're the stem anatomy and the root anatomy is going to be different depending on whether or not you are a monocot or a dicot. So there's not a lot of notes per se, there's just a lot of diagrams, and so some of this will just be talking about the different diagrams. So, okay. So there's four major parts to your, five technically, major parts to your STEM anatomy. We're going to start with your dicots. So, I think what I'm going to do is go over the drawing, and as I'm going over the drawing, I'll interject what's on the slide. So I think that'll be the easiest. So when I label it, then I'll tell you what the job is because that's what's on your notes there. So okay. So the first big doodle that I've drawn, and this is on the front. So all of these have to do with the rest of these four doodles have to do with a dicot stem anatomy. So if you were to take a cross section of a stem, this is what you would see in a dicot. So we talked a little bit about this, I believe, on the last set of notes about your primary growth and your shoot-apical meristem. So you can see that I've drawn the epidermis with its cuticle, that waxy layer around it. In this drawing, I've also included some trichomes. So with your epidermis, just remember that it's there to kind of protect your cell and your stem, and it can have that cuticle layer around it, which is going to depend on your plant as to how thick that is. If you're going to be in a place that where water retention is vital to the plant, so very hot areas, it potentially would have a thicker cuticle. And there can be those guard cells to let oxygen in and out, but that's usually only on the younger part portions of your stems. So, okay, then that inner tissue right underneath the epidermis, that's the cortex. So it's just there for storage and some support. So it's going to be made of parenchyma cells for storage and sclerenchyma cells for support. Then you've got your vascular bundles there, which is on the next slide. So I'm going to skip that for now because it's a little bit more involved. And then the pith is that center set of tissues just right directly in the center of the stem. And then that's also made of parenchyma cells for storage. And then the tissue found in between your vascular bundles is going to be what's called your pith rays, and those are also made out of parenchyma cells. So, so that's basically what a cross section of your dicot stem would look like, minus the vascular bundles, which we're going to talk about now. Your vascular bundles are going to be your primary xylem and your primary phloem. The xylem is going to be on the inside part of the vascular bundle, and your phloem is going to be on the outer area. Don't forget, this is produced by your procambium, which was made by your shoot apical meristem. So your shoot apical meristem made that primary meristem of the procambium, which then made the primary tissues of xylem, primary xylem, and primary phloem. So I've listed it in order from the outside in. You've got primary phloem, then you have a row of undifferentiated procambial cells, and then your primary xylem. Okay, so you can kind of see there in that first diagram how I've got that layer in between, separating the two so they don't actually touch. Um, so, so yeah, I'm trying to think if there's anything else here. If you then look down below, you have the you've got a larger blown up portion of your vascular bundle. So I've drawn the two orientations there. Your epidermis would be on top and your pith would be on the bottom. So this would be vascular bundle towards the top of that particular dicot stem, orientation-wise. So you're on the outer edge. We're gonna start from the top or towards the epidermis, and then we'll go down towards the pith end. Right at the very end of your vascular bundle, closer to the epidermis, is what's called a phloem fiber cap. Now, in both the roots and the stems, your phloem can be divided into two different types, your protophlloem and your metaphlloem. Your protophlloem is always the older phloem, or same goes for your protoxylem. Those are going to be your first formed or your oldest. And then your newer phloem or xylem, which will be your metaxylem or your metaphlloem, that'll be newer. So, which makes sense why that's closest to that row of undifferentiated procambial cells. Since the procambial tissue or procambrial meristem produces the xylem and phloem, it would make sense that the newer formed phloem and xylem is closest to the procambial tissue. So you've got protophlloem, metaphloem, your layer of undifferentiated procambial cells, and then I probably should have reordered this on your notes here. It should then probably read metaxylem and then protoxylem if you want to go in order. Okay. So that kind of goes and looks closer at those. It blows up that primary xylem and phloem or your vascular bundle. The last diagram on the bottom right there, which is a cross section of your dicot stem as it's growing, it's not actually your vascular bundles aren't actually in a bundle yet. It's more of a layer, I guess I would say. So they haven't been sectioned off into those smaller bundles. So you can kind of see that you definitely still have that ring. You have a full ring of procambium cells. And then you have this mass of primary phloem. On the inside, you've got this mass of primary xylem. And then eventually, yes, they'll shape into those vascular bundles that we're used to seeing in a more mature dicot stem. So there's your dicot stem. We're going to look now at your and compare that with your monocot stem. So on the back side, and how I was looking, I've just oriented some cells here to kind of show you, to remind you about the intercellular space where water can sometimes come in, come into your stem. So in between the cells. Okay, so your monocot stem. Just what the outside is going to look very similar to the dicot stem. Still got your epidermis covered by a cuticle, which again can depend. This thickness can depend on your plant. You can have trichomes on the outside. Sometimes you can have guard cells. Now, here's where the major difference is. You can kind of see that the vascular bundles are just kind of put wherever. They don't have a particular orientation. They're literally just spaced throughout. There is no pith, which also means there's no pith rays. And there's no cortex, that outer tissue between your vascular bundles and your epidermis. It's not there at all. So basically everything in the middle and on the sides of those vascular bundles is just parenchyma cells or storage cells. Nothing special. And that's, instead of being called the pith or the pith rays or the cortex, it's going to be called ground tissue. So nothing fancy there. On the right, I've drawn you some pictures. And I misspelled peripheral there, sorry. So I missed this. In addition with the parenchyma cells on the peripheral, you also have some sclerenchyma cells. So cells in the peripheral and are going to be parenchyma and sclerenchyma cells for some support. So anyway, so now moving on, to your vascular bundles. So as it's developing, your general arrangement is still kind of similar to that of the dicot vascular bundle. You're still going to have, again, it's oriented with the epidermis towards the top and the center part of the cell. Can't really say the pith because it doesn't exist, so we're going to say the center. So you still have that same orientation, except the main thing to note is that there's no row of undifferentiated parenchymas or procambial cells in between your xylem and your phloem. Okay, so you're still going to have your protophlom on the outside and your protoxylem on the outside, and then your metaphlom and metaxylem there on the inside. But there's no actual row of undifferentiated procambial cells. So they're going to be in direct contact with each other. So this, I always thought of it as a weird looking face when I was drawing it in botany, but this is a more mature monocot vascular bundle. So the other one was, like I said, was very generalized. So the one on top is very generalized. On the bottom, I've actually drawn out a little bit more. So there is some sclerenchyma tissue that goes around those vascular bundles or surrounds your vascular bundles. Okay, we'll start on the top and work our way down. On the very, very top, that I don't know how well you can see in the drawing, but it's kind of a darker black spot just on the very, very top, almost like a hat, I guess, or the very top of the hat of the face. So that's their protophlom. So there's not a lot of it there. Then you've got your metaphlom, which is kind of that crisscrossed area that's a little bit thicker. It's made of seed tube elements and their companion cells and parenchyma cells. Then you've got your primary xylem, which is your metaxylem, is going to be toward, I guess, around what I would call the eyes area. The and then the bottom part is where the protoxylem used to be. So as it's forming, you've got this, what I'm going to call the mouth. This is kind of just a big empty space. It's called a protoxylem lacunae. There's pieces of wall in there, but it's mostly just a big empty space. And then you've got some vessel elements there, kind of in the middle of the metaxylem. That's what the VE means. Or those would be what I would call the eyes. So that's basically the structure of a monocot vascular bundle, which looks way different than your dicot vascular bundle. So alrighty. The last thing that we're going to kind of talk about with these groups, that's just kind of thrown in here, are some stem modifications. Sometimes they occur above ground and sometimes they occur below ground. So we're going to talk about the above ground stem modifications that plants can produce. The first being above ground, and the first one is a tendril. So these are going to be coily little appendages that a plant uses for support. It's going to wrap around something, whether it's another branch, a tree, the screen on your window, but it's going to grab on somehow. So think ivy, grapevines. And the reason why, it does it for support, but it also allows it to grow out, get taller, so kind of helps it with the skeleton, if you will. Ivy uses something special at the very end of it, at the end of its tendrils. Peas also have tendrils, by the way. They use these little suction things called holdfasts that allow them to attach to buildings and walls. So that's one thing that can come out of your stem, or one modification that can come out of your stem. The next thing is the cladophyll. These are leaf-like structures. They're not leaves, actual leaves structurally, but they act like leaves. They are able to go through photosynthesis, but that's pretty much it. So they do have chlorophyll, but they're just very, very flat leaf-like branches. You've got a stolon or a runner. These are there to allow them to connect to other plants that might be next to them. Think strawberry plants. They have stolons or runners that connect the whole patch. So that's another thing that can come out. Last next one that's an above ground modification would be a thorn. Obviously, they're very pointed. They're there for protection for the plant. So you can't actually rip them out because it's embedded within the stem. I mean, if you do rip it out, the plant can die. So because you're ripping out inside tissue there at that point. So okay, moving on. We've got underground stem modifications next. The first one is what's called a rhizome, and I've drawn a nice little picture there for you with a plant flower. It's my rendition of a flower. Should have been an art teacher, I know. So the rhizome is going to be part of, again, these, you might think of these as roots, but they're not because they're part of the stem. So a rhizome is going to be a large, fleshy, horizontal part of the stem that grows underneath. From that, you can get roots. It's not actually a root, though. There's ginger, that's actually stem, but it's not. We call it ginger root, but it's technically not a root. It's part of the stem. So I've drawn you that lovely growth, or that mass that's underneath the ground, and then you've got the roots coming, the real roots coming out from that. Your next one is a tuber. That was always a fun word, I thought. It's a structure that comes off of that rhizome. And so think of a potato. Potatoes are tubers. So I didn't label the rhizome in this sense. So because I didn't even draw it really. So but the tuber is, I think the tuber, yeah, I didn't actually draw the rhizome, so technically that's not anatomically correct. It would be that root, that main root there should probably be a little more lateral, and then from that you get your tuber, which would be like your potato. So structures that come off of your tuber can be lateral buds, which would be like the little eyes on your potato. So lateral buds. And then the last structure would be the corm that would develop underground. This is really similar to a rhizome, but it looks like a bulb, but it's not. So like onions are bulbs, but not corms. Your crocus and your gladiolas are considered to be corms. And if you look at your picture, you can see why it would look very similar to a bulb, because it's got paper leaves surrounding it. The roots come out from that, but it serves as storage. It just happens to be underground. So anyway, so that kind of wraps up your primary stem anatomy. You've got a worksheet now, I believe, that'll be due tomorrow. And then tomorrow we'll also look at your root anatomy. So if you have any questions, you feel free to email me. I will be in later this afternoon. I'm just off for half a day today, but I'll be back 5th hour. So you can definitely, if you have questions, send me an email. So yeah, and I hope you have a good day.